Hello students, welcome to my class. In the last session, we discussed about balancing of chemical equations. Today also, we are going to discuss some more examples of balancing the chemical equations. See, here I have taken an example of that is silver. When silver combines with hydrogen sulfate, so when there is a reaction between silver and hydrogen sulfate, it forms silver sulfate plus hydrogen gas. Silver sulfate and hydrogen gas is produces. See, I have already mentioned what to do during the chemical equation balancing. See, that time I have mentioned first we have to write the number of atoms at reactant side and product side, that you have to list out. So that first we will list out these numbers. See here, Ag is there, so okay, Ag, H, hydrogen atom is there and sulfur atom is there, right? In these reaction product, where is there? Hydrogen is there, and hydrogen sulfate is there, silver is there, and the sulfur is there. So these are the major elements that are present in this reaction, that is involved in this reaction. So now we will write number of Ag atom. Ag means silver atom at reactant side. What is the number of Ag at the reactant side? Yes, it is correct, it's 1. Whereas at this side, so what is the number of Ag? Yes, you are correct, it is 2. Yes, that means Ag is not balanced. The next number of S atom. S atom means sulfur atom. Here how many sulfur atoms are there? So 1 sulfur atom is there. Here also 1. So it is a balanced one. And number of H atoms. So H atom here is 2 and here also it is 2. Okay, no problem. 2, 2. Right? Now see, coming to the balancing of them. See, this is also equal, this is up. Only imbalancing is the silver atom. So that what I am going to do is I will multiply this Ag atom by 2, because to balance at both the side the Ag atom, so I will write coefficient 2 behind Ag, and when I multiply 2 with Ag with 2, so that also Ag also become 2, and now both the side Ag is balanced. Both the side Ag is balanced. See, these already, you know, this is balanced, and already S atom is balanced, and already the H atom also balanced. Now the chemical reaction is balanced. So therefore the balanced chemical equation now 2Ag plus H2S, formation of Ag2S plus H2 gas. So this is one of the examples that we have to balance. So which was unbalanced first, and now it has become a balance. Now it is a balanced equation, right? Okay, shall we take one more? Okay, fine. Next one is, this is what KOH means. What? Yes, it is potassium. So potassium hydroxide. Yes, and the potassium hydroxide, you know very well, the potassium hydroxide, when it is combined with carbon dioxide, this is the base, and it's combined with carbon dioxide, it forms its carbonate, then potassium carbonate plus water will form. Potassium carbonate plus water will form, right? See whether the equation is balanced or unbalanced. First check out. See, for that what we have to do, what elements are involved here? There is a potassium atom is there, there's carbon atom is there, and oxygen atom is there. Write this, those atoms at reactant and product side. Yes, so we'll write first. So number of atoms, see the number of atoms at reactant side, what is the K number of atoms at K atoms at LHS side? Yes, it is of 1, right? It is 1. But at product side, see, it is 2. Yes, here 1, here 2 is. Now, number of carbon atoms, okay, number of carbon atoms, here it is 1, here also it is 1, both the side equal. Yes, number of O atom, oxygen atoms, here it is 2, no, not 2, here it is, yes, it is 2. Number of oxygen atoms, so here 3, 2 plus 1, here 3, and here 3 plus 1, that is 4. So one more I left, okay, number of hydrogen is not written, number of H atoms. How many H atoms are there here? 1 is there, here 2 are there, H2, here H is there, right? So now 1, 1, 3, 1, 2, 1, 4, 2 means complete is in balance. And how to balance it first? First we will balance the potassium. So balance it by writing 2 as a coefficient for KOH. So when I write 2, now the KOH, in the KOH the K atoms become 2. So both the side the potassium are balanced because here also 2 is there, here also 2 is there. Now it is okay. Now number of carbon atom, here it is 1, so there also it is 1, no problem to balance it. No need to balance it. Again, number of O atoms, the oxygen atoms, let it be. And number of hydrogen atom, check first. Number of hydrogen atom is 1 is there, here 2 is there. So here also when I multiply with this, it becomes 2. So both the side, this is also balanced and C also balanced now. So what to balance now? See, balancing of oxygen atom, right? So balancing of oxygen, how many oxygens are there here now? 3, 4 are there. So when I multiply with this, the number is again changed. Yes, number of oxygen atom. So here plus 2, here 2 oxygen plus 4 will become 4 now. 3 become 4 because when I multiply to this one, so it also multiply to hydrogen also. So number of hydrogen atom is increased. So number of hydrogen atom is now 4, and this also it is a 4. Now balance. See both the side. 2, 1, 4, 2, 2, 1, 4, 2. Yes. Now what we have to do is, now what is the balanced chemical? Just by putting a coefficient 2 here, we balance the whole chemical equations, right? So this is what the balancing of chemical equations. Okay, is it clear? Potassium hydroxide when combined with carbon dioxide produces potassium carbonate plus hydrogen, so plus water, right? Now we'll go to the next one. Next is sodium. You know very well, the sodium is very reactive element. You know, it's a very reactive metal also. So this is the sodium. Well, sodium when react with oxygen, when burns and very vigorously react, produces sodium oxide. See whether the chemical equation is balanced or unbalanced by counting the number of atoms at both the sides. See, first we will count the number of sodium atoms. Sodium atom here 1, here 2 is there, okay, it is a balance now. Number of oxygen, here it is 2, here it is 1. So there is a imbalance. So to balance the chemical equation, what we have to do first, we have to balance the sodium, right? Sodium, how many are there here? Sodium 2 are there, here 1 is there. I will write here 2 and I will write 2, right? Now both the side balance. And when I write 2 here, here the sodium is balanced. Now oxygen, see number of oxygen atoms at LHS is 2, whereas at RHS side is 1. To make it 2, I have to multiply by 2. So this is 2, now it becomes 2 But when I multiply with 2, the number of sodium atom is increased by 4. It is increased by 4. So again it is imbalance. So what to do? Instead of 2, I will multiply this with 4. When I multiply with 4, here also sodium 4, here also 4, sodium 4, 2, 4, 2. Now the chemical equation is balanced. Is it getting? Okay, are you understanding? I hope you will understand better, right? So we'll take one more example, that is magnesium. So magnesium Mg, when react with nitrogen, it produces a magnesium nitrate. It's an unbalanced chemical equation. Magnesium react with nitrogen, produces magnesium nitrate. So now we are going to balance it now, right? First elements, magnesium is there and nitrogen is there, right? Nitrogen atoms is there. Well, magnesium, how many magnesium is there? Here, how many? 1 magnesium is there. I will write 1. And next here, what is there? 3 are there. So Mg3 is there. Number of nitrogen atom here 2. Here also 2. So they are balanced now. So our work is to balance the magnesium. How many are here? 3 are 3. So therefore I will multiply the magnesium by 3. When I write here 3, the number of magnesium at the LHS side, yeah, that also it become 3. It become 3. So this is also balanced and this is also balanced. Now the equation, see, so simple it is that just putting 3 behind this, balance it both the side. Okay. And I already mentioned in the last video that during balancing chemical equation, you can change only coefficient but do not change the subscript. The subscript don't change. Yeah? Instead of multiplying the magnesium atom with 3, don't write 3 here to balance it. This is totally wrong. Okay. So that's why only you have, there is a rule there, during balancing chemical equation you can change only the coefficient but not change the subscript. These are subscript. Okay, so don't touch the subscript. Right? Is that clear? Okay, fine. We'll take one more example, that is, okay, 1 minute. Fine. Now, so one more example is there, that is sulfur. Okay, sulfur. So sulfur plus F means fluorine, so formation of sulfur fluoride. Yes, is this chemical equation balanced? No, it's not balanced because here 8 S are there. Yes, here 8 S are there and 2 F are there, but here S is 1, and whereas see this subscript 1 is there and there is no, there is a 6 are there, here 2 are there and 6, so completely it's unbalanced. Now we are going to balance it. Yes, and what to do during balancing, I said? Yes, okay, that's elements, number of atoms of these elements that are involved in this chemical reaction. So number of F atom, fluorine atom. So how many are the reactant side? That is 2. How many are the product side? There are 6. Number of sulfur, that is of 8 at LHS, and at RHS only 1 is there. So it is in imbalanced chemical equations, right? Now we are going to balance it, this chemical equation, right? See, first I will balance the F atoms. Okay, see what is the number F here? 2 is there, here 6 is there. So to make it 6, I will write 3 behind this. 3 of 2, now it becomes 6. So both the side it is balanced. Yes, and here 8 is there, and here only 1 is there. So what I have to do? I have to make it as 8. When I made it 8, when I multiply S with 8, okay, the S is balanced now, it become 8. Both the side it is equal. But at the same time, the number of fluorine atoms is increased. So how many? 8 of 6 is, what is that? 46. Okay, got it. So 46, it become 46. Now it become, so not 40, 48. It become 48. Yes. And what is the number here? See here, 6 is there. What is the first one? 2. F2 is there. So divide by 2, and what will it become? It will become 24. Now multiply this with 24. Yes, I will write upside 24. 24 of 2 is 48. So now both the side is balanced. Now the chemical. See, S8 plus 24 F2, arrow mark 8, S F6. Now the chemical equation is balanced. Are you getting? This chemical equation, now it is a balanced chemical equations. See, there become 6, 8, and sorry, it is not, it is become 24, no? Right, 24. So 48, this also become 48. Because of writing 24, it will become 48. So 48, 8, here also 48, 8. So now the chemical equation is balanced. Okay, okay for you? Any confusions? S is there. First I have written S was 1, here S was 8, here S was 1, and I multiply with this 8. When I multiply 8, the S atom become balanced, whereas the number of fluorine is increased. So 8 of 6 is 48. So here only 2 was there. So 48 divided by 2, 24, that is 24 into 2, that becomes 48. So here also 48 and here also 48. The chemical equation is balanced. Alright. And take one more example. That is, what do you know? C3H8. Yes, you're right. It's a propane. It's a propane, right? Propane is an hydrocarbon, you know. So when hydrocarbon combines with, when burns, it combines with oxygen, and after burning, what will happen? You will get, after the combustion, at the end of the combustion, the product are the carbon dioxide and water. This is a very common combustion reaction. So when propane combines with this one, it produces carbon dioxide and water. So now balance this chemical equation. Very interesting. See, number of carbon atom. Yes, 3 are there. Here 3. What is the number of carbon atom in this side? Only 1 is there. This is only 1. Number of H atom, here 8. Number of H atom here only 2. Right? And number of oxygen is 2 here. Right? This is only 2. 2 plus 1, here 3 are there. Right? Right. Is it clear? 3, 8, 2, 1, 2, 3. Right. This is the atoms that represented both LHS and RHS side. Now going to balance it first. Number of carbon atoms. So what is the carbon atom here? 3 is there. Here 1 is there. So to make it this 3, what I am going to do, I will multiply the CO2 by 3. When I multiply CO2 by 3, the carbon atom become 3 at both the side. At the same time, due to multiplication of carbon dioxide with 3, the number of oxygen atom also increased by 6. 6 plus 1, it becomes 7 now, right? 3 of 2 is 6, 6 plus 1, that is total oxygen atom is, first it was 3, now it becomes 7, right? And okay, next what is the hydrogen atom? So number of hydrogen atom here 8 is there, here only 2 is there. To make it 8, I will write it 4. So 4 of 2 is 8. So both are equal. But again there is a change in the number of oxygen, because 4 plus 6 total, it is not 7, it becomes 10. Yes. So it will become a 10. Now we are going to balance the oxygen atom. Here oxygen only 2 is there, here 10 is there. So 10 by 2, that is 5. So 5u you multiply, 5 of 2 is 10, and both the side it become 10. So now the chemical 3, 8, 10, 3, 8, 10, now the chemical equation is